Welcome to clickmeproject.com. This is our project title: Cost-effective, reliable and secure workflow deployment over federated clouds. And this is our project abstract. This paper presents a novel algorithm to deploy workflow applications on federated clouds. First, we introduce an entropy-based method to quantify the most reliable workflow deployments. Secondly, we apply an extension of the bell-LaBlaw multi-level security model to address application security requirements. Finally, we optimize deployment in terms of its entropy and also its monetary cost, taking into account the cost of computing power, data storage and intercloud communication. We implemented our new approach and compared it against two existing scheduling algorithms: Extended Dynamic Constraint Algorithm (EDCA) and Extended Bio-Objective Dynamic Level Scheduling EBDLS. This is our project data flow diagram. First, start the program and follow the client's workflow. Client's workflow means they selecting the data and sending to the clouds. After selecting the data with the client and upload the packets to the server, the internet network, and in the internet network, and they send it to the lower bound security. Lower bound security in the sense we after uploading the packets, we must splitting the packets into different splitting the data into different packets and monitoring that and monitoring the data on the for lower bound security. The lower bound security available for different IP address passing data passing through the different IP address and the packets. And after sending the packets, the cloud server will receiving the packets from the client after if it's any time to ready to receive the client's packets. And after receiving the packets, if this way the cloud will be scheduling the files for storing the storing into the VM machines in the different cloud servers. After using the cloud scheduling algorithm or like size-based scheduling or optimization and scheduling after scheduling it will store it into the and after assigning the virtual machines in the cloud server and store it the packets into the virtual machines based on the scheduling. The scheduling is based on the size based or load balancing. After completed the scheduling and after storing it and stop the program. Now we are going to see the demo of our project, and now we have to run the project. Click on home.java and right click on it and choose run file to run the home page of our project, and the home page is displayed on the screen. And click next button to go further into the project, and the total overall menu is main screen is on the screen, it's on the window. And go to cloud setting. If you want directly go to cloud operation, we can't go to cloud operation without setting our cloud. Okay, so then go to cloud setting and set IP address and socket number. The 1111 is a socket number of our cloud server, and how many virtual machines we give. One virtual machine, physical virtual machine, and enter the number of virtual machines, physical machines, and the virtual machines which is in the physical machine, which we give 3. Okay, then give next button. Click on next button. After clicking the next button, we setting the size of the VM machines and we select three virtual machines, virtual machine 1, virtual machine 2 and virtual machine 3, and set the size of the virtual machine 1 and the size of the virtual machine 1 is small, and the size of the virtual machine 2 is, and the size of the virtual machine 2 is large, and the size of the virtual machine 3 is extra large. We have to set the size of the virtual machines in the cloud server and start the services. After start the services, we can go to the client operations, browse the file. We can choose only text file because we can split the text file into the content of the text file, and give next button. After giving the next button, split the files. The files are filtered into packets and show the number of packets. The files are split into 7 packets, different packets, and click next button and set the cloud IP. This is the cloud IP which I am setting in the cloud server, and the socket address is be given 111, and the IP address and the socket address is displayed on the screen, and generate a key, and it's after generating the key it will be encrypted using that key, and the key is generated, and the secure data flow is generated, and it's a lower bound, and send it. After click send button, it's a receive. The data is encrypted successfully and all packets sent successfully. Okay, and here show the packets. We receiving all the packets and show the packets. These packets are all encrypted. The encrypted mode. The cloud covering the encrypted file only, which is used in the lower band security. Then merge the packets into one file, which is given to the data, and we have completed the client server operations. After completed the client server operations, we get the report from the report for cost optimization, which is scheduled by the cloud server, and the number of packets is 7. The sending number of packets also 7. So we have completely received the 7 number of packets. Sending and number of packets are equal, and total time it's in the nanoseconds, and the fault free time is here, and the reliability is 4. Then next, the cost factor, number of file is 1, just only one file, and the size of the bytes is file is bytes is 1 here, and assigned cloud virtual machine 1 is assigned, and the size is the virtual machine 1 size is small. The size of the size is very small compared to the virtual machine, compared to the data, and the total cost is 190. And the reliability, check the reliability. After the increased system and the proposed system reliability is there, and the cost is compared to the cost is proposed system is lesser than the existing system, and security level is almost higher than the existing system, and close the window. Thanks to listeners.